Welcome to Ask and Learn.
So we are given this non-homogeneous linear recurrence relation, and we want to do various things. So first off, we want to prove that an is equal to n times 2 to the n is a solution to this recurrence relation. So to show this, we start off with the right-hand side. So the right-hand side is equal to 2a sub n minus 1 plus by 2 to the n. So to figure out what this a sub n minus 1 is, if we use this and we shift all n, we convert all n to n minus 1. So this is a n minus 1 is equal to n minus 1 times by 2 to the n minus by 1. So then this is going to be 2 times by n minus 1 times by 2 to the n minus 1, and we'll plus by 2 to the n. Then we multiply these two together, so it's n minus 1 times by 2 to the n minus 1 plus 1, so that's just n, and we're going to plus by 2 to the n. Now, if we expand this, this is going to be n 2 to the n minus by 2 to the n plus by 2 to the n, so this is just n 2 to the n, which we know is a sub n, which is your left-hand side. So therefore, this is a solution to your recurrence relation. So to find all solutions to this recurrence relation, what we have to solve is we have to solve for the homogeneous part of this equation. So specifically, we solve for a sub n is equal to 2a sub n minus 1, just the homogeneous part. So then the characteristic equation is then r is equal to 2 times by 1. So you just have r is equal to 2. So then your solution is then a sub n to the homogeneous part. The homogeneous part is going to be a sub n is equal to alpha sub 1 times by 2 to the n. So then to your solution to your homogeneous part, so the solution to everything is just going to be the sum of this and of this. Yeah. So then the solution is then to the inhomogeneous equation is going to be alpha sub 1 2 to the n plus by n dot 2 to the n. So your solution to the homogeneous part, which is when 2 to the n is 0, and your solution to the non-homogeneous recurrence relation. So we want to find a solution with a0 is equal to 2. Well, from before, we have a sub n is equal to alpha sub 1 2 to the n plus by n times by 2 to the n. So if we substitute 0 in, this is going to be alpha 1 times 2 to the 0, that gives you 1, so it's alpha times 1. So plus by 0 times by 2 to the 0, so then this is going to be equal to alpha sub 1. But from your initial condition, we need alpha 0 is equal to 2. So then this thing is going to be equal to 2. So then your solution is then going to be given by 2 times by 2 to the n plus by n times by 2 to the n. And we can factorize this as n plus by 2 times by 2 to the n, a sub n.